for your pleasure, here is exercise 1 for lesson 25. Today we're going to work on geometric interpretation of solutions of a linear equation. All that really is, it's a fancy way of saying that we're going to graph linear equations. Make sure in your binder you are on page 151. And yes, we are skipping lesson 24. We may go back to it tomorrow. We might not, but don't worry about it. So before we begin, just an important term that you need to know. Simultaneous linear equations or systems of linear equations is just when you have two linear equations together. That's linear equations. And remember, what does it mean to be a linear equation? A few things that we've talked about so far with this unit for a linear equation is that it forms a straight line. If you remember the standard form of a linear equation, looks like ax plus by equals c. And something that you may not remember about linear equations is that the exponent of x and y, the exponents of the variables, they can only be two numbers. The exponents of the variables have to be 0 or 1. So that's just a few things when we're talking about simultaneous linear equations. Okay, so the proper notation for linear equations. So when we're talking about systems of equations today, you're going to see it in the form of y equals mx plus b. And you're also going to see it in the form of ax plus by equals c. You've already seen linear equations that look like this. So let's go ahead and take a look at exercise 1. Before we do that, how to determine your answer. If we're graphing points, our solution is going to be an ordered pair. So it's going to be written in the form of xy. And our solution is going to be where our lines intersect or where they meet. So again, our solution is going to be where our lines intersect. It's going to be represented as an ordered pair. What that means is that it's a solution to both equations in the question. So I'm going to show you exactly what that looks like. So now let's take a look at example 1. We need to sketch the graphs of the linear equation, of the system, of the linear system on the coordinate plane. So we have our first equation, 2x plus y equals 12, and y equals 5, 6x minus 2. So the first thing is, if I want to graph the equation 2y plus x equals 12, first thing is that's not in the standard form of a line. Do you remember how we solved this yesterday? We did it two different ways. We put x equal to 0, and we also put y equal to 0. Remember, we figured out what that ordered pair is, and we graphed those 2 points. So I'm going to plug in x for 0 first. So I have 2y plus, and instead of 0, instead of x, I'm writing 0 equals 12. So I have 2y plus 0 equals 12. Again, that plus 0 vanishes, and I'm left with 2y equals 12. Divide each side by 2. And the y value that I get is 6. So remember, when you have an ordered pair xy, my x value is 0, and my y value is 6. So my ordered pair would look like 0, 6. So now, when my y is equal to 0, it's 2 times 0 plus x equals 12. And 2 times 0 is 0 plus x equals 12. Again, that plus 0 plus vanishes, and I'm left with x equals 12. So that ordered pair would be 12, 0. So on your graph, on your coordinate plane, make sure you plot those 2 points, 12, 0 and 0, 6. So 12, 0 would be over here. 0, 6 would be up here with my mess of everything else. Let me erase that. Make sure, if they're a linear equation, make sure you use your ruler to connect the points. Make sure if it's a line, make sure you're putting arrows on the end. And make sure you label it with your equation. Okay, so now that I have that equation graphed, I'm going to focus on my equation y equals 5, 6x minus 2. That looks pretty easy. I'm going to figure out, remember, it's y equals mx plus b. I'm going to determine my slope and my y-intercept, and I'm going to graph from there. So my y-intercept is -2, so I'm going to graph on my line a point at -2. My slope is I'm going to rise 5 and run to the right 6. So for my y-intercept, I'm going to rise 5. 1, 2, 3, 4, 5. And I'm going to move to the right 6. 1, 2, 3, 4, 5, 6. So notice right there that my lines intersect. Right at this point, right here. So I could continue with this line. I could rise 1, 2, 3, 4, 5. Let's count it again. 1, 2, 3, 4, 5, 6. So my next point would go here. Go ahead, use your ruler, connect your points to make your line. Make sure you have arrows on both ends, and make sure you label your equation. And also make sure that your line goes through your entire equation. Okay. That's y equals 5 over 6x minus 2. So now we need to name the ordered pair where the graphs of the two linear equations meet. So take a look. Again, my equations intersect right there. So that ordered pair would be it looks like 6, 3. So in order for us now to figure out that our equation is that this solution is accurate and it works, we need to solve in part C. So we need to verify that the ordered pair named in part A is a solution to our first equation, 2y plus x equals 12. Remember, this is the equation that we graphed using intercepts. So now all I'm going to do, my solution we said was 6, 3. My x value is 6, my y value is 3. All I'm going to do is I'm going to plug these values in to my equation and make sure that it does in fact equal 12. So I have 2 instead of y, it's going to be 3. And 2 and 3 are attached with multiplication, so I'm going to put a multiplication sign in between them. Plus x, my x value is 6, and it should equal 12. So now I can simplify. 2 times 3 gives me 6. I'm going to bring down everything else. 6 plus 6 equals 12. Again, I have to simplify one more time. 6 plus 6 is 12, and 12 equals 12. Remember, since I plugged my solution into the equation and it works, that verifies that it is a solution. So now we got to go ahead and we got to verify that our ordered pair 6, 3 is also a solution to our equation y equals 5 over 6 x minus 2. So again, same thing. I'm going to plug in my x value and my y value. So I have y is 3 equals 5, 6 times x. And my x value is 6 minus 2. First thing I need to do is I need to multiply 5 over 6 times 6. And again, I could put 6 over 1, and I could multiply those fractions across. So I get 30 over 6. Oh, hey, wait a minute. 30 over 6. I could divide those both by 6, and I get 5 over 1. 5 over 1 is really just 5. All right, so now let's rewrite that. And I'm going to rewrite this portion is 5. So I still have 3 equals, and it's 5, and I'm going to bring along my minus 2. So 5 minus 2 gives me 3, and 3 in fact does give me 3. Therefore, I know that 6, 3 is a solution to this ordered pair. So what that essentially means is that 6, 3, again, is a solution to both equations. Make sure you go on Google Form and you answer the questions for this video.